In this lab, stoichiometric determinations, we are going to determine the mole ratio of two reactants in a unique way. So this is what we're after. You will actually know the identity of your reactants. So going into this, it won't be a mystery. Your lab group will either be assigned to react 1 molar sulfuric acid with 1 molar sodium hydroxide, or 1 molar HCl with 1 molar sodium hydroxide. So again, you already know the mole ratio going in, but if you could set that to the side and allow the experimental data to lead you. The reaction of these acids and bases, as most acid-base neutralization reactions, are exothermic because we're creating water, a very, very low enthalpy product. They're exothermic, and the greater the extent, the greater the quantity of acid and base, of course, the greater the amount of heat that's going to be released. We've already talked about limiting reactants and have an understanding of that. So you could have one reactant that's in abundance, but if you only have a little bit of the other reactant, that of course will determine the extent of the reaction. So what we will be doing in this lab is adding different volumes of your acid and your base. They're the same molarity, so the different volumes will deliver a different quantity of moles. The volumes that you're experimenting with always total 50 milliliters. So you will be adding, and we are looking for the greatest change in temperature. That will reflect the greatest extent of the reaction, or where one of your reactants is not acting in a limiting capacity. As the lab directed you, you'll be combining different volumes, and we're going to take the guidance of those volumes that are shown to us. You have some freedom though how you set up your data table, and eventually how you graph your experimental results to determine the mole ratio experimentally. If you want, you can just create a table of the volume of acid, this may be HCl for your group, and the volume of NaOH. You could also have a column for moles of those things. You are denoting the initial temperature of both solutions. They will be sat at room temperature. So as long as you're noting it initially, and you do need to measure it. So even though we're working in lab in the same amount of time, you do need to measure that initial temperature. When you combine them, you're looking for your highest temperature reached. Again, it's exothermic. And then ultimately, this is what we're after, looking for the greatest change in temperature. Just some safety precautions. We're of course working with acids and bases. 1 molar, you could have the option of wearing gloves if you would feel more comfortable, an apron of course. Just be careful in the handling, and we know how to clean up spills on the lab bench, on our papers, also on our skin. Now, both the sodium hydroxide and acid solutions are clear and colorless. So you want to make sure that you're not mixing them up. When in doubt, just dump it down the sink and get a new sample. However, we can avoid this by clearly marking our glassware. I'm even going to get 2 different size. These look, of course, very different because of the heights. And I'm going to denote one of these to be my acid. It's going to mark it A. You could actually write the identity, the formula, and then B for my base. Now, I'm going to measure the volumes of the solutions with grad cylinders. And I'm going to have a dedicated one for my base and a dedicated one for the acid. Let's just be as efficient as possible. Now, we're going to be utilizing our LabQuest and temperature probe, and of course our coffee cup calorimeter. This can get a little top heavy once we put our probe in. So to make sure you don't lose any of your quantities, let's stabilize it in a 600 mil or 1,000 mil beaker. Now, it doesn't really matter which solution you begin with in the cup. However, I would encourage you to use the solution of greater volume because of course we want a certain depth of the liquid for our temperature probe base to just trust that it's measuring the temperature that we're after. So whichever quantity is greater, pour that in first. It just takes about 30 to 60 seconds for the probe to equilibrate. Make sure that it's reading a nice level temperature, denote that. Then you'll add either the acid or base, the other solution. Make sure you are agitating. Because 50 milliliters, it's not going to be very high. We can do this lab without a lid. Even though we know to be insulated, we should have a lid. But we're okay for this lab. Make sure you're fully stirring and not crazy so you poke a hole in the styrofoam cup, but just enough so that you're getting it as homogeneous and all reactants in contact with each other, and then you're denoting the highest temperature. It should plateau and then begin to fall. Now, between trials, make sure that you are rinsing your probe with pure water and drying it, and rinsing the cup and drying it between trials. I would suggest too that you give it a good triple washing with water before you do your first trial, and make sure that it is nice and dry. Don't reuse your paper towels. You can of course pitch those after each drying. Once you've gone through all your trials, then with your lab partner, really think about, okay, what do we need to graph? How do we analyze this change of temperature information to reveal the mole ratio of your acid with sodium hydroxide? The work of the pre-lab, of course, will help you think through that. Again, you have some freedom. You want to make sure that you are conveying all measurements in your data table, but you have some freedom as to how you determine what you're going to graph. Enjoy. This is a really neat way that we can apply our understanding of stoichiometry, but yet do some calorimetry. Enjoy and best of luck.